How exactly does DBMS fetch the data from the database? That is the recipe for query processing. Query optimization is a step in query processing that helps us to fetch the data in the best way possible. If you haven't watched the video on query processing, I'll link it here for you. Let's take a very simple example. If I have to go to work from my house, which path will I select? Obviously, the one that is short or has the least traffic or that requires less time and petrol, that is, resources. Why? The less time you have to spend traveling, the more time you can invest in doing other things like reading something or exercising or eating a healthy breakfast or even sleeping a little extra. The same thing happens when the DBMS is trying to fetch the data from the database. It prefers the path that requires less time and the one that uses the least amount of resources so that it can tackle other requests. Otherwise, the system may get weaker over time. This is query optimization. Hello learners, welcome back to Constant Learners. Today we are discussing query optimization in database management systems. We'll address what query optimization is, we'll discuss why it matters and how we can achieve it. We'll also understand the steps involved in query optimization, and in the end we'll see if 100% optimization is possible or not. So stay tuned and let's begin. Introduction to query optimization. Query is a question. In case of DBMS, it is requesting information, a statement that is used to request information. Optimization comes from the word optimize, which means the action of making the best or most effective use of something. So what is query optimization? Imagine your database as a busy restaurant. Every query you write is like an order sent to the kitchen. The faster and smarter the kitchen handles the orders, the happier your customers, that is your users, will be. But what if the chef is confused and runs around looking for ingredients every time instead of having them organized and ready? That's where query optimization comes in. It helps the kitchen, that is the database, serve orders, that is queries, quickly, using the best route and the least resources. The database system analyzes different ways to answer your query and picks the fastest plan, just like a chef deciding the quickest way to cook a dish. So query optimization is the process of choosing the most efficient way, that is, the best way to execute an SQL query. And how does that happen? There are multiple ways of processing a query, but by selecting the one with the lowest cost, not just in terms of money, but also time, CPU, memory, and disk access, is known as query optimization. Now the question is, how can we achieve this? See, sometimes there are multiple ways to write the same query and get the same answer. We have seen many examples while discussing different relational algebra operations. So some ways are faster and more efficient than others. The database system analyzes different ways to answer your query and picks the fastest plan. Our goal is to reduce the query execution time and improve the system performance. Let's take an example to understand this. Let's say we have two relations. One is the employee with attributes employee ID, name, department ID and salary, and another one is the department table with attributes department ID and department name. Now suppose we want to find the names of all the employees who work in the HR department. Only the HR department, right? Employees in the HR department, right? So how are we going to do that? So this is our SQL query. Select employee name from employee table. Join department on employee.department ID is equal to department.department ID, where department.department name is equal to HR. So in short, what are we doing? We are selecting the department name is equal to HR, and on that department ID, we are going to join the employee table with the department table, and then we are going to select the employee name from there. Now, the optimizer can process this query in two ways. First is join the two big tables, that is the employee table and the department table. We are joining on the department ID, right? And then we apply the filter, that is select department name is equal to HR, right? And then we project the names of the employees that are in the HR department. But what happens in this case is it joins all the employees with the departments, with all the departments, right? Which produces a large intermediate result. And then it filters where the department name is equal to HR, right? So this becomes an elongated process. Right now the tables are small, that is why the intermediate table is also small. But in case of huge databases where the tables are extremely large, in that case this intermediate results becomes very, very large and time consuming. It also uses a lot of systems processes. Thus, this is not an ideal way of finding the solution to this query. The another way to do so is by first selecting only the HR department from the department table. This reduces the size of the department table, right? What are we doing here? We are selecting department name is equal to HR from the department table. Now we will join this intermediate table with this employee table on the department ID, right? This gives us a much smaller and faster result, right? This intermediate table is quite small and this operation also requires very less time. And finally, we can project the names of the employees in this HR department, right? Doing the filter first reduces the number of rows and columns, right? And makes a join faster, because that is our goal, to reduce the number of rows and columns the database has to handle at each step. It's better to avoid select all, which leads to a full table scan. This scans every row and it's going to be very slow if there are thousands of employees. Rather than writing a generalized query, we can write a proper query that targets only the required output. That is, only fetch what you need, like ordering just a burger, not the entire menu, right? Now let's discuss the steps involved in query optimization. Let's break this down into bite-sized pieces, a step-by-step breakdown of query optimization so that everyone can understand how this works, even if you're just starting your database journey. Alright, now the optimizer comes after the parser and translator, and it uses the statistics about the data to fetch the result, right? This we have to remember while discussing the steps. First step is generate a logical query plan. So after we get the parsed query, this parsed SQL query is turned into a logical structure using relational algebra, that is in the form of relational algebraic expression, just like this one. This is a logical query, not an SQL query, right? Example, SQL join is translated into a logical join operation, right? Next step is to apply equivalence rules, that is logical transformation. Rewrite the logical plan into multiple logically equivalent plans because we need the same result. But as we discussed, the same query can be rewritten in multiple different ways to fetch the same result, right? These transformations aim to reduce intermediate result sizes, that is fewer rows or columns. Example, push select operations closer to base tables called selection pushdown. Next, generate physical query plans. For each logical plan, generate different physical plans using various algorithms and access methods. Example, use index nested loop join, sort merge join, or hash join. These we are going to discuss in further videos. Next step is to estimate the cost for each plan. Estimate the resource cost, that is CPU time, memory, disk I/O, network, for each plan using the statistics. As we discussed, the statistics is used to fetch the data by the optimizer. Okay, the optimizer uses the statistics about data to efficiently fetch the data from the database. Example, if one plan scans 1000 rows versus another scanning 10,000 rows, the former is the cheaper one. Next is to choose the best, that is the lowest cost plan. The optimizer selects the plan with the least estimated cost. This plan is passed to the execution engine. Now, the lowest cost does not always mean money, right? Of course, money is an important factor. The machine should be used less number of times. That is, the processing should not take a very long time. That is also important, right? Then the resources used must be minimal. Of course, because otherwise the database will wear out after time. The DBMS will wear out after a certain period of time. So it's not just about money straight away, but it's also about the time, the resources. Alright? And thus, when the plan is passed on to the execution engine, the query is executed and data is given to the user. Right? Now, why query optimization matters? Query optimization is very important because it helps us to fetch the faster results for the users. It puts less strain on the database server. It is possible to handle more users at once. That is scalability. It saves money on hardware and cloud costs. When a user writes a query, they focus on what they want, not how it should be executed. The DBMS has multiple ways called query plans to fetch the same result. Query optimization ensures the system selects the best and most efficient plan. Alright, now let's address our final question. Is it possible to achieve 100% optimization? So ideally, no, it's not possible to attain 100% optimization due to various reasons like the structure of data, workload, complexity of queries, limitations of optimizer, etc. But we can try to improve the optimizer's performance as much as possible. Alright, so that was all for query optimization. In the next video, we'll discuss how heuristic optimization is performed. Don't forget to like, subscribe and hit that notification bell to catch the next part of our query optimization journey. Drop your questions in the comments below and I'll address them as soon as possible. Until then, keep those queries optimized and thank you so much for watching.